That's the result for prototyping. 4 parts to make the board. We are connected in LinuxCNC. I actually used this machine to make manufacture PCB boards. The way to do it is we can, as I show here, we can cut the traces on the CNC machine to isolate the traces, and then we'll have the drill file for size 0.8 mm, 1.2 mm. The edge cut is the sides of the board, and so the way to do it is first to make the traces, then we do the holes, different size of holes, then we cut the edge. That's the G code for 0.8 mm, 1.2 mm edges. That's live session of LinuxCNC on the machine. When we start production run, we have to home the machine. I home it in the center, X, Y, Z. We have placed the tool in the center. That's the job. We say position reference to the part. Say I am 15 mm Z, X and Y are 5. Now we would run the job. And the way I do this is to export the traces as a DXF file and export the manufacturing files, which include the drill file. Then I open a parser. The parser takes the standard drill file to output specific G code, and the CAD parser takes the DXF to make G code with proper configuration for the tools, diameters of the holes, 4 parts to make the board. That's the result for prototyping. We can have a small shorts, so we need to check that every trace is properly cut, conducting and isolated, and then we spray to make the insulation on this side. This board is not TB6560. That's actually the chip that's at the core of this board. This board is used by CNC machines to drive stepper motors. It's a 4-channel board. The design is quite old for this board. It's maybe 15 years or more. Now the issue with CNC control is that it needs to be real-time. Therefore, this is parallel port controlled. The software I use is actually LinuxCNC. We have power supply for the board, digital inputs, parallel port control, 4-channel stepper driver. This one is 3.5 amps. They have a surface mount 2.5 amps. Now I got an issue with this board. First of all, the channel for X burnt when I tried to measure with a scope, and the ground probe shorted 2 of the pins. Instantaneously, I had a short circuit and channel failure on the output. I configured X to be on the 4th channel in software, and I could use the CNC machine again. 24 to 36 VDC input. That's the diagrams, and that's the decay mode, and that's the current mode, limit switch. That's Toshiba datasheet for the driver. We can see there's direct output from the pins to the coils, measurement current shunt. It doesn't seem though to be short circuit protected. If we short circuit the coil, what happened is that I burnt the chip almost instantly. Now there could be an issue with the design of the board. I'm not sure. I didn't investigate what should happen on a short circuit with this board, this IC. Now we see the micro steps. That's 8, I guess, and 16. The output is almost sinusoidal. So we see the logic over here: reset pin, clock, configuration, direction, and step. Thank you. Sorry for the quality of the video. We're building a new prototype of this machine, and I will share the process. Hope to see you later for the test of the machine. Thanks for being here. Thanks for being here.